This is a, I don't know how old you are, but some of you might remember some of this. You can remember where you were in 1986 for a start. 1986, believe it or not, was quite a good year. Right? There was two things, technology-wise, that happened in 1986. Number one was the internet came online. Okay? Where would computers be today if we didn't have the internet? I mean, that's an amazing thing. It pushed the computers way up. The power became greater and greater, and that helped something else, which also was brought about that day, and that is, oh, sorry, will that play? Can't get to it. Oh, sorry about that. We'll have to move on to the next one. That's a thing. A guy called, that you see up there, Charles, he was the inventor of 3D systems, or the person that put it all into being. He actually registered that year stereolithography, which we now know as 3D printing. So this is where he comes. He's also the founder of 3D systems, whose machines I sell. Okay, this is just some of the people that are actually using it. You've got Boeing, 3M, Siemens, Motorola, Caterpillar, Fluke, GM Motors, Honda, BMW. They all use 3D printing now. It's a standard tool for them. Excuse me. Right, a guy actually approached me many years ago and asked me if he could buy one of our machines. I said, yeah, no problem. He said, I want your machine to produce itself. He said, you happy with that? No problems whatsoever. I said, how many do you want and where do you want to put? He went on from there to develop a machine that he put on open source that anybody could make. So anybody could have their own 3D printer. That was called the RepRap, and all of the desktop computers, 3D printers you see today are developments from that. Okay. Some of the different types of technology that's out there. Some of you may know these, some of you might not. FDM, fused deposition, and this is where they actually put a string of plastic, ABS or PLA through a jet and just let that put it down layers. I'll show you all about that in a minute. LOM, this was one of the very early ones, and there was quite a few developments in that. I'll explain a little bit about that in a few as well. SLA, now this is one of the founder ones. This is where stereolithography actually comes from. It's where they use the fluid and they laser etch the fluids. SLS is a powder version of the same thing, selective laser sintering. Inkjet, something that when I came into it, I came in 2002. So I've been into 3D printing for as long as I can remember. Multi-jet. This is a development from the inkjet. It's in the sort of principle. The only difference is instead of setting the powders you put down, you actually lay the material down. But instead of using a bubble jet printer, you use something called piezo printhead. Piezo printers use a crystal. I don't know if you're familiar. If you put an electromotive force onto a crystal, it expands and it gives out noise. If you actually crush a crystal, it will give out an EMF, electromotive force. So they're quite useful things. They put these in a piezo printhead, and when they excite them with electricity, they expand, bing, and they'll pump out whatever material's in there. And in this case, it's a form of ABS or a light-sensitive polymer. DMP, direct metal printing. If I get time, I'll go through that at the end. This, I think, is the future of 3D printing, and what's really going to make it, put it on the face of the map. EBM is another form of metal electro-beam melting. They've been doing this for donkey's years. I used to look after them in aerospace. I was senior electronics engineer for their maintenance in Weybridge in Surrey. Electron beam basically is a whole load of beams, and where they cross, that's where you get your maximum power, which means you can actually go through other things. They don't actually do that with electron beam 3D printing, but that's what they used to do, is go through metals and fuse one metal to another metal, and you couldn't actually get in there, but you used to fuse the metals and I've seen stainless steel and copper and things like that all welded together, and it's quite impressive because there's no burning or anything, because it's in a vacuum, and there's a little bit radioactive too. This is some of the people that are in the business. These are all competition for me, but they're all bloody good competition because they all make good machines. I don't think there's any really bad 3D printers. They've all had a hell of a lot of work put into them. Stratasys has come alongside us. Object, they joined Stratasys a little while back, bought out by Stratasys. They come from Israel. MakerBot, this is one of these small ones that came from the FDMs that were put out through the RET Wrap. More I recognise it. EOS, they do a lot of metal printing. They also do some of the big stuff, the SLAs and SLS. They're a good competitor. Envision Tech, there's a slightly different. I'll come back to that one again in a minute. But there's Arcam. This is your electron beam people. EMCO, this is a local company. And one of the guys, and I'm not quite sure of his title, so I won't give it to him. But we used to work together. He came to work for us when he first started in 3D printing many years ago, Brian, and now he's quite high up with EMCO Technologies and has to travel backwards and forwards from the south east every week to do his job. FDM. Most desktops 3D printers now are FDM. There's more of them out there than there is of any other type. And it's feeding the plastic, as I said before, to make a three-dimensional model. This is basically what they do. I don't know if you can see this all right, but you've got, you can have a whole number. We do up to 3 different heads. You can either put the same amount of material, same colour material down all 3, can't see the benefit of that, but there could be different colours. If they're different colours, it means you can get a tricolour model. Alternatively, you could use one of them, say, as a PLA, and the other one, say the ABS, as a support material. The ABS breaks away quite nice and easily, but it could be a material that washes away. So you could have 2 printing and the other one printing all the supports in it. Just another picture of how it actually lays it down, layer upon layer, which it makes it a little bit on the poorer side. But there's some of the ones that that's one of our ones up on the left-hand side there. MakerBot in the middle. I don't know all of these. That's another one of our ones, and that's part of the Stratasys range. That's that one down there. LOM. Quite an interesting history to LOM. They started doing it, and it was what really made it take off. So they're really quite responsible for how it's developed. But most of the ones that did this went out of business years ago. There's still people doing it, okay? And the one in different type, but they're still long because it's a layering technology. The SD300 is one of them, the cubic technologies. This does it with like a plastic film. And EMCO, which is the paper machine, just puts a sheet of paper in all coloured and that. But they're still long. Some of the original ones that did it this way put the laser and then lasered it. You see the mirror up on there. Well, that's a flying mirror, and it all goes like this. And what it does, as the beam hits it, it then directs it to the surface, the laser, and cuts out. Or in this case, it would be cutting out a sheet of paper or a sheet of acrylic or whatever, just cuts through it and leaves it stuck to the one on the top, because it will then go and do a lattice work on the top, which most of these materials have got something, either a glue or something that will stick the top one to the next one down. The only problem with the early LOM machines was they used to catch fire, and this didn't make them very popular. You can see again how it's doing it, and it's just putting layer upon layer, as you can see. All the file formats for this generally are STL. All CAD systems output STL files. Colour printers can use VRML, PLY, 3ds, WRL, all these ones. We want anyone that carries colour, right? You'll find all of them are capable of doing that. This is one, it used to be one of our machines, quite a good one. This uses a slightly different, it's what they call a phase change material, which is a light sensitive polymer. And what they do, they fill a tray up full of it, the plate comes down, and underneath they've got a projector. The projector projects a picture, or one layer of that SDL file, which hits a mirror and fires it straight up onto this membrane, which the material's sitting on top of. That sets that off. The vacuum then pulls the thing apart, it lifts up, more material comes down, back on it, just keeps building that out. But the reliability of them has not been good, so I don't think they're going to be doing them anymore. This is another one, uses exactly the same sort of print, in as much as they project underneath, and it's in VisionTech. They've been a little bit more successful, but they do get problems with them. Object, these are very good machines, very good competitors, right? They use a similar sort of material that we do, only it tends to be a lot thinner, the viscosity, get a nice shiny finish on it, but the accuracy is probably a little bit better on the project machine because it's a slightly stiffer material. Object 3500, that's the one that we've got a lot of the models up there for. This is just a bigger version of it. They do dental machines and they provide dental materials for it, and they can produce castings for crowns, bridges, all sorts of orthopedics in the mouth and partial frameworks, just by building up with different materials. But the one on the end would probably be a wax, so that would go for a lost wax and then they'll make a steel, that type of material. This is some of the details you can actually get down to. Some of the sizes of these holes are tiny, 0.5, you know, it's quite small. SLS, now this is a powder system. The material's dragged across a chamber, and once again with a scanner, which is a laser scanner, it burns or melts the surface of the material, dropping it down every time, filling it up again with powder, and then re-lasering it. This is SLA, similar sort of thing, only instead of filling the chamber with powder, they fill it with fluid. The fluid then is lasered. The only trouble with this is because it's not a powder, it's not supporting itself. So if you actually built an SLA part, you would have to build supports on it to hold the part up if you had any overhanging parts. This is one that the sort of format that they come in. These are some of the bigger ones. Now these are big machines. I've got these in aerospace, Rolls-Royce, all them sort of people. This is the sort of thing that they favour. Once again, this is metal printing. Okay, this would be a dental machine. Right, this is the smallest one. They start around about £200,000, so it's not something that you go into without some sort of investigation. The SLA and the SLS, I say, they differ in quite a way. One's using powders, the other one's using phase-sensitive polymers. But one of the advantages of SLS is the fact that you can mix and match materials. You can use nylons with glass fills, which you can get up to something like 200 degrees on the material. So it's quite useful in a lot of applications, especially in electrical industries, where they got where they want to make parts to hold in hot oil and stuff like this. And you can glass fill it, so it can have some very high wear characteristics as well. But this is the same for most machines. This isn't just ours. Now we're coming to the plaster-based materials. This is where I first came in 2002, and the machines, I can assure you, nothing like this then. Let's start off in the top corner, is a small one, going up to the next one, which is a colour. This has got 3 million colours. The top one has colours, but it's only 64 colours. Then over to the top right there, you've got the 660. This one uses all colour binders, where the other one uses a tricolour print head, Hewlett Packard, basic stuff. But they go up to 6 million colours. The quality of the parts of them are infinitely bigger, and they're big too. The 860 that you see on the bottom, this is the sort of thing you make investment casting models with. It's quite something. This is how they work approximately. You've got a hopper on the back, which all the materials return to, and you've got a build chamber in the front. It pulls the power across. It goes back and prints one layer of an STL file on it. Every time it does that, that build chamber drops down one. So it's dropping down 0.1 thickness of a human hair every time it does it. Okay, this is just some of the parts that they've done in the medical field. For making up, so they've taken an MRI scan with somebody, and they've got parts that have got to be repaired, eye sockets, all this sort of thing. They can actually go and make the parts up and fit into the skull or the jawbone or whatever. This is quite a common thing. And for making up jigs to fit in the legs when somebody's been shattered skiing or motorbikes and sort of things. It's one of the biggest ones, the 860. This actually is a massive lump of casting. But that one would go in and they'll make sand molds out of that. Just some of the colour ones. These bits can be made to look absolutely real. Depends on how much work you want to do to them after you've actually finished them, not just great. People pick them up, think they're real, but that really is down to the expertise of the person that's doing the finishing. War guns, the old Jupiter. These are no bigger than about 50 mil high, those chairs, but you can see the grain on every single one. Historic. These actually work. My son's great fun flicking brakes backwards and forwards down the dining room. My missus loves it. Architectural. This has got to be one of the best machines out there for architectural models because of the size that it can print and the speed it prints. They print around about an inch an hour and in full colour. So you can get some really nice looking models of them. Just to show you somebody. That's actually one that's been made, that's a photograph, that's actually a hospital. These are power plants. That is actually Newcastle. That's a complete GIS file of Newcastle. This is actually done, you can actually download it from Google. And a GIS file has got loads of files in it, and some of them are you get colour GIS files as well. So you can actually print off all of that, and you can, while you're doing it, print all the colours that are actually there. So I don't know how many files there are actually in it. There's about 4 or 5 different file types in a GIS file. Terrain maps from ultra scans. EBM, electron beam, and this is basically what it does. It has coils and deflection coils, and they bend and shape the beams as they come out to hit the surface. They'll flick them backwards and forwards across the part to make pools up. One of the big advantages with EBM, we don't do it by the way, but one of the big advantages with EBM is the fact that it's really hot, so you don't have to go through the heating up process afterwards to relieve any stresses that might be in the actual build of the part. That's it for that one. Right, if I can take you back to the other one now. I don't know if anybody's interested in metal printing, are they?